Alright, so we'll take a look at your homework from the last section. Alright, so let's see, I asked you to do problem number 9, and it says write the first 5 terms of the sequence, assuming n begins with 1. Use the table feature. Okay, we don't need that. So for problem number 9, it says we have a sub n is equal to 6n over 3n squared minus 1. And I'm going to have n up here, and it wants the first 5. And number 9, 17 was on here. And 21. Alright, so if n is 1, this is going to be 6 times 1 over 3 times 1 squared minus 1, which would be 6 over 3 minus 1 is 2, which is why the answer is 3. If you were to plug in 2, you'd have 6 times 2 over 3 times 2 squared minus 1, which would be 12 over 12 minus 1 is 11. All right, and let me just check one thing here. All right, 625. All right, so for number 9, it goes 3, 12 over 11, and then you'd get 9 over 13 here, 24 over 47, and then 15 over 37. I showed you where that comes from. All right, for number 17, the first term would be 3 to the first over 1 factorial, which is 3 over 1, or 3. The second term is 3 to the second over 2 factorial, which would be 9 over 1 times 2, which is 9/2. Just keeping this pattern going, for number 17, you would have 3 9/2. This would actually be 9/2 again. And then you would get 27 over 8, and then 81 over 40. For the second one, if n is 1, you would have 2 times 1 minus 1 times 2 times 1 plus 1, or 2 minus 1 times 2 plus 1 is 3. By the same token, for the second one, this would be 2 times 2 minus 1 times 2 times 2 plus 1. 4 minus 1 is 3. 4 plus 1 is 5. This is 15. All right, if we continue that out, we get 35. 63 and 99. All right, what else do we have here? I had asked you to do 25, 27, and 31. For 25, so if we know a sub n is equal to 2 to the nth power over n factorial, it's asking us to find a sub 10. So a sub 10 would be 2 to the 10th power divided by 10 factorial. You actually have a factorial button on your calculator. If you take it out, it's under the PRB option. So 10 is really 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. Or you could just hit 10, the PRB button, go over to the exclamation point, and you'd get a really big number, 3628800. 2 to the 10th is 1024. And if you take 1024 and you divide that by 10 factorial, you would get let's see here. My calculator doesn't like that number, but you would get, this would reduce. You could keep dividing by 2. It would reduce to 4 over 14,175. All right, for 27, 27 is easy. 27 just says we're doing a sub n is equal to 4 to the n, 4 times n over 2n squared minus 3. A sub 10, if you plug in 10 here, 4 times 10 divided by 2 times 10 to the second minus 3 is 40 over 200 minus 3. And that'll reduce to, let me see here, 27. Oh, it actually wants us to find a sub 12. So this would be 48. 144 times 2 is 288, which is just reduces to 16 over 95. All right, and then we have 3133. It's a recursive formula. So for problem number 31, it's saying a sub 1 is 3. Figure out what, well, it's giving us the recursive formula. A sub k plus 1 is equal to 2 times a sub k minus 1. All right, and for 31, it's asking us to write the first 5 terms of the sequence. So we have a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. A sub 1 is 3, and according to the formula, to get the next term, a sub k plus 1, so the next term, right, which would be 2, where k is 1, we would have 2 times a sub 1 minus 1, or 2 times 3 minus 1, which is 2 times 2 is 4. So we're going to take 2 times 1 minus the previous term. All right, so 2 times the previous term minus 1. 2 times 3 is 6. 2 times the previous term minus 1. 2 times 5 is 10. 2 times the previous term, 2 times 9 is 18. All right. Let's see what else. That was 31. Number 33. 33 says a sub 1 is equal to 2. A sub 2 is equal to 6. And the formula is a sub k plus 2 is equal to a sub k plus 1 plus 2 times a sub k. We want to get the first 5 terms. All right, so to figure out a sub 3 is really just 1, so k would be 1. And that's how we would figure this out. So a sub 3 is equal to, now k would have to be 1, right? Because we have to get 3 here, so k would be 1. So this would be a sub 1 plus 1 plus 2 times a sub 1. A sub 2 is 6 plus 2 times 1, or 2 times the first term, would be 6 plus 4 is 10. A sub 4 is going to equal, now in this case, if we want to get 4, k would have to be 2, right? 2 plus 2 is 4. So k is 2. So this is going to be a sub 3 plus 2 times a sub 2. A sub 3 we figured out was 10 plus 2 times 6. 10 plus 12 is 22. Good Taylor Swift song. And then a sub 5, a is, if we're looking for 5, k would have to be 3. So this would be a sub 3 plus 1 plus 2 times a sub 3, which would be 22 plus 2 times a sub 3, which is 10. So 22 plus 20 is 42. All right, so that would be 33. And then we have 73 and 75. All right, so these are fun. I like reducing factorials. So 73 says we have 12 factorial over 4 factorial times a factorial. And then 75 was we have n plus 1 factorial over n factorial. All right, well, we talked about how to do this. I mean, I could write 12 as really 8 factorial, and then times 9 times 10 times 11 times 12. We could have 4 factorial, and then we'll have the 8 factorial. The reason why I rewrote the top is so that these would cancel. And then if you just use your calculator, I'm going to do 9 times 10 times 11 times 12 is 11,880 divided by 4 factorial. 1 times 2 times 3 times 4, which is 24. And this will reduce. So 11,880 over 24 is 495. This last one's really easy. N plus 1 factorial is just 1 times 2 times 3 times 4 times whatever up to n minus 1 times n plus 1. Well, this whole thing right here, that's n factorial. So they would actually cancel, and our final answer is just n plus 1. All right, thank you very much. Have a nice day.